branch, evening hors d'oeuvre meeting discussion with Bob Mather. Though this is a no-host hors d'oeuvre part of the event, so I hope you've taken care of the hospitality aspect yourselves. Unfortunately, the way we would do it virtually just wouldn't really quite be the same thing as actually having your scotch on the rocks and something tasty in front of you. But in the event that you thought maybe we could do that virtually, I'm sorry we can't. You'll just have to pretend. As I said, I'd like to welcome you all to the CASI Fall 2020 virtual series of presentations. We're putting together these virtual presentations using a variety of different content approaches. One of them is to work with our branches and to help them organize a program that would be effective in a virtual environment online. Another form of content is with technical sessions, and in particular this year will be, and we are currently structuring a number of technical sessions based around the Astro 2020 conference that unfortunately had to be canceled due to COVID. We have, I guess, at least a dozen sessions currently that it looks like we'll be able to put together. Several of them have been firmly committed to, and we have dates for them as well. On October 27th, we'll be presenting a panel of Canadian government representatives who are going to talk about the space regulatory environment, both in Canada and internationally, the importance of that, the way it is achieved, how it's defined, how it has a bearing on the players in space, and so on. I think this will be quite an interesting discussion amongst the folks in the Canadian, senior people in the Canadian civil service who have use of space assets and whose activities are affected by the regulatory environment in which they operate these assets. On the 4th of November, we'll be having a workshop on the space situational awareness / space domain awareness. This is being organized by Defense Research and Development Canada, and this promises to be a very interesting event that will take up most of the afternoon on the 4th of November. For those of you who are interested in how and why we need to be aware of the space domain, what is the space domain? How do we maintain awareness of it? What benefits are there to us of that awareness? What are the international implications of the practice of space domain and space situational awareness? These are factors that will be brought up during the workshop, which will be a very interactive activity. And on the 11th of November, we will have what would be a regular virtual Astro session built around that concept. It won't be a workshop this time. It'll be a more conventional session with several presentations being made and a moderator, and then some chat back and forth at the end between the audience and the speaker. So these are the things that are firmly on the books right now. We hope that we will continue as we have done in the past, and that's been our mandate since 1954, to bring together the aeronautics and space communities in Canada to nourish your interest in these topics, to enable you to get to know each other and to work well together and collaborate and to celebrate your achievements. So that's what we exist for. A housekeeping point or two. I'll be handing off in moments from now to Jeff Bird, who is co-chair of the Ottawa branch, and he will introduce our speaker today, Bob Mather. The chat function, we're using Zoom as the platform for today's event. And the way Zoom has recently restructured itself is such that the chat activity is either directed to just one person or to all. And so if you want to participate in the chat function, in other words, to be aware of the chat back and forth, and to participate yourself, perhaps by submitting a comment or a question, you'll need to click on the chat button that you will find somewhere on your screen, depending on what device you're using for this event. So I think that is pretty well all I have to say, other than to encourage all those of you who are interested in the kind of programming that CASI has to offer in this virtual arena, to encourage you to become members of CASI if you're not already. And in that way, you can be sure to be kept informed of the programming options that we'll be offering over the course of, well, the foreseeable future, but certainly through until Christmas and undoubtedly beyond. One of the benefits, by the way, of the virtual environment is that you don't have to go anywhere other than your home, your office, or your smartphone to participate, which means that it's typical to attract more participants than you might otherwise if you were bringing together an event in a face-to-face manner. And it turns out that we have registered for this event nearly 100 participants, which is probably more than we could expect in a face-to-face Ottawa branch meeting, although I know Jeff has been working hard to reach that lofty goal. It's still, you know, when you've got to think about traffic and parking and, you know, the weather and, you know, the time it takes to get from A to B, these are all impediments to participating with the kind of ease that we can do in the virtual environment. So again, I'd like to warmly welcome everybody who's with us today. And at this point, I'd like to thank Jeff in advance for his hosting of the balance of the meeting. Thank Bob for being our speaker, and to hand off to Jeff. Over to you.
Greetings. Thank you everyone for coming to this. I do re-underline the fact that you have to depend on your own hors d'oeuvres, but we thought we would keep the content very interesting and get you ready for your dinner. We'll try, Bob will work to get the presentation itself done within the 45 minutes, and we'll try and get everything done, have a question and answer period that will go on for some time after that as people are interested, and we'd field questions from the chat room or maybe some audio ones. So we'll try and keep it to about 45 minutes because people are tired at the end of the day. I wanted to welcome you on behalf of the Ottawa branch, and as you may, most of you will know, we have the CASI is a national organization aimed at advancing the science, engineering, art, and business of aerospace in Canada. We're aimed for this talk and for all of our activities on to help and contribute to the building and support of a broad community across disciplines. So the aerospace community for sure, but with our partners at Carleton and Ottawa U, the mechanical engineers that are there are also seen as a great part of our community. And in addition, the systems and computer science people as well are important parts of this community. So we are partnered with the Carleton Mechanical and Aerospace Society, who give us lots of enthusiasm and are bringing new members to us, and also a nascent University of Ottawa student CASI group that Matt Seri is leading and trying to build. In addition to that, I would like to recognize the other people that I can see online or who have attended the Toronto branch, people like Chris Hayball and some of the other people there. And I see a number of other friends of CASI and Society, Dave Zimick and Paul Vanderpool and Jill Davis and certainly Paul Penna. And we would welcome you all, and thank you for your time to participate in this. I hope it will be an important learning experience for you. And I guess to underline the national aspect of this beyond the Ottawa branch, we recognize registrations from some 85 different people. And I just go down the new towns that the Ottawa branch will claim ownership over, including Acton, Almont, Beaconsfield, Brampton, Calgary, an interesting city now in Ontario, Chute-à-Blondeau, Dorval, Ennismore, Fredericton, Gravenhurst, London, Ontario, Longueuil, Milton, Mississauga, Montreal, Mountain, Napanee, Negjuak, New Brunswick, North York, Richmond Hill, Saint Laurent, St. Marc-sur-Richelieu, Toronto, and Vancouver. And also to acknowledge about half of you are already wise enough to be CASI members. And I would encourage those who are not to come and join our community and contribute to us. And you can see that at casi.ca to join. In addition, so with that kind of introduction, I would then go to Bob's introduction. The people who participated or who called into the June meeting will know Bob already. Many of you will know him from his previous number of careers. As an introduction or a summary kind of the introduction that was available in the registration information, I would highlight Bob's multi-sector experience in the assessment of technology innovation. So his background at Rolls-Royce, Pratt and Whitney, and Transport Canada, in particular Transport Canada in government to corporate delegation for innovation and long-range over water operations, and also his important experience and contributions at the Aerospace Industries Association, where he worked on safety and environmental policy development and government interaction. And as many of you know, he's been a supporter of CASI for many years. So with that short introduction, I would pass the screen to Bob for his presentation. And please, as you think of them, add questions to the chat room. If there are points of clarification, I'll try and interrupt Bob, or when he stops to breathe and ask for feedback, I can insert some of those questions for a clarification. But please do use the chat room to start your own discussions and augment questions and comments that people might do. I see that as one of the benefits of this while Bob is speaking. So without further ado, I welcome and pre-thank Bob for his time in putting this together, and enjoy your hors d'oeuvres. Bob, to you.
Okay, thanks a lot, Jeff. It's a pleasure to be here, and welcome all 85 of you to my small office. With any luck, I'm going to get the technology working to start the presentation. I'm not going to go through any huge detail. But the title of the presentation is A Canadian Success Story. But I believe that this is not working very well. Sorry for the long delay.
There we go.
Now I can start. Yeah, I styled the presentation The Canadian Success Story. I think the industry as a whole is a great success story because it's nationwide. There's highly skilled people working in it, and overall it contributes about 25 billion to the GDP and in excess of 200,000 jobs. This was all from 2018. The industry has been really quite stable for the last many years. Of course, the step function introduced by COVID is going to be somewhat different for us now. We have to look at what comes after COVID and hope that the industry will be able to weather this storm as it has done many times before. What does the industry consist of? It consists of manufacturing, repair, and overhaul, and the military side. There's a lot of a lot of important imports on the Canadian military side. I'm going to be talking more about civil aviation. These figures come from an information report put together by Innovation Science and Development Canada and the Aerospace Industries Association. It's the 2019 report, which actually is compiled using 2018 data. From this slide, you can see Canada's industry is across the country. Mostly, it appears mostly centered in Ontario and Quebec, but in fact, the number of jobs are distributed across the country, more or less in relation to the population.
Bob, if I can just stop you for 1 second, we're actually in the speaker notes view for your presentation.
Oh, thanks. Okay, I'm not sure how to change that because I need to, okay.
There you
Is that better?
Beautiful.
Sorry about that. I'll go back just to give you a better view of that slide. You can see that it's 70% manufacturing and 30% repair and overhaul. There's a defense and a space element in there. This shows the national profile of our industry. And as I was just about to say, the industry is distributed more or less in proportion with the population across the country. We also have a global presence. And you can see that we're ranked pretty close to the top in flight simulators, civil engine, and civil aircraft. Where does all this success come from? This comes from a gradual work over the years by many, many people. So I'm going to take de Havilland as an example of the way this success has appeared. So going from the Tiger Moth to the Q400, I call that a success story. My career was mainly in engine design, manufacture, and certification. So there'll be a little bit of a bias towards that. We're going to take a somewhat narrow look at the industry, really. There's many, many other companies like Bombardier and Bell and CAE who've contributed their part as well. So we're going to put not exactly blinkers on, but we'll take a look at what de Havilland has done over the years to start with. So 1936 to 1945 is an example really of how a branch plant of a foreign company builds success. Early de Havilland aircraft were shipped across the Atlantic in crates, assembled and test flown and shipped to their customers in Canada. Towards the end of this period, de Havilland Canada wanted to build a bush aircraft, but the corporate decision from London was that they would build a trainer, and the Chipmunk was the answer to it, the aircraft on the right of the screen. This became the DHC-1. It was the de Havilland Type 85, I think, from the UK, but it was the first designed and built aircraft in Canada. The next in the line was the DHC-2, the Beaver, which was finally the bush plane that the de Havilland Canada company wanted to build. The plan was to put an English engine, the de Havilland Gypsy Queen, at around 300 horsepower in this aircraft. But as the design progressed, they needed more power, and it ended up with a Pratt and Whitney R985. But by 1976, there were over 400 of these aircraft on the Canadian register alone, and many, many more operating around the world. In fact, 61 other countries. This is the latest iteration of the Beaver on floats, which many of them operate on, and it has a gas turbine engine in the front. This gives more horsepower and less weight. Next in line, DHC-3, this was the Otter, an airplane that's about twice the size of the Beaver. Once again, it performed a civil flying role and a military. The two white aircraft on the right of the screen are actually wearing their Australian Air Force uniforms. You can see the kangaroo in the middle of the roundel on the side of the fuselage, whereas the one in the roundel in Canada is the same color scheme, but instead of a kangaroo, we have the maple leaf. Next came the de Havilland Cariboo, a slightly larger airplane. This was in 1954. This aircraft has room for 30 passengers in the civil row and up to 32 fully equipped troops. A later version with gas turbine engines in it. This photograph I downloaded from the Viking Air Company website in Sydney, BC. I'll talk a little bit more about Viking later on. DHC-5 came next. It's the Buffalo. This is a result of a US Army competition to have a STOL tactical aircraft that carry a half-ton truck, a howitzer, or a Pershing missile. Now, STOL is short takeoff and landing. Sorry for the alphabet soup to start with. Now, this was an open competition, and de Havilland submitted their bid along with 8 other US companies, and they won. So the aircraft was produced, and it went into service in 1965. Production of the Buffalo continued with a pause in 72 and resumed again in 1974. Production finally ended in 1986. The design of this aircraft saw service in research roles. This is a picture of a Buffalo with 2 Rolls-Royce Spey engines in it. Now, these engines were used to provide pressure air into the wing that was blown out over the flap structure at the back to provide lift at very low forward speeds. Now, this way of providing extra lift at low speeds turns out to be rather noisy. Another version of the same thing is the Buffalo with 4 turbofan engines mounted high on the wing, and air is blown externally over the flaps, again, to give more lift at low speeds. Moving on to the Twin Otter, the DHC-6, initially produced in Toronto and shipped around the world. Now, these aircraft are being produced by Viking Air on the West Coast, in fact, on Vancouver Island. This was really quite an obvious step forward from the DHC-5 to add more passengers and more operational flexibility. Although it was designed as a bush utility aircraft, the airlines of the day were finding these aircraft very useful to provide short-haul operations, city center to city center, and they gained quite a bit of popularity. The fact that the Twin Otter made inroads into the passenger world meant that de Havilland were starting to consider a larger aircraft. That led to the design and production of the DHC-7, the Dash 7 as it was known. You can see that this has 4 fairly large propellers, and again, blowing air over the wing to ensure continued lift at very low speeds. Now, in order to get short takeoff and landing performance, it's necessary to have approach and landing speeds and takeoff speeds on the aircraft quite low. The reason for that is you can't accelerate passengers like a Formula One car. It tends to spill the coffee or more valuable liquids. And also, when the aircraft lands, it's no good just putting bigger brakes on, because the passenger comfort becomes very important. So the Dash 7 was de Havilland's entree into the passenger world. Next in line was the Dash 8. The Dash 8 was really an evolution of the Dash 7, and it so happened that Pratt and Whitney Canada had the right engine available to make this a twin rather than a 4-engine aircraft, because This would give operational flexibility for the operators. The one thing that as a civil aircraft, it was not terribly attractive was the fact that the interior noise of a propeller aircraft is somewhat higher than a turbofan powered aircraft. So de Havilland introduced in the Dash 300 model some dynamic balancers, dynamic vibration absorbers inside the fuselage. This was quite successful and did reduce the noise even more. The next step forward was the Q400. This had a much bigger engine, and it had active harmonic damping inside the aircraft, and it became quite acceptable to the passengers. Now, I've gone through from Tiger Moth to Dash 8 Q400 in short order. So what enabled this to take place? Well, I've called the PW100 family of engines the enabler. And I'm going to spend a little bit of time later on explaining to you where this engine came from and why it was designed in the way it was. But first of all, I'm going to go over very briefly the history of aircraft engines and aircraft propulsion. Starting, of course, with the Wright brothers in 1903, they designed and built an engine of their own that produced 12 horsepower. Now, they were smart because they thought their airplane would fly on only 8 horsepower. So they at least had a little bit of power in hand. Won't dwell on that because their success and what it led to is obvious. Now, as aircraft got more utilitarian and bigger and more useful, there was a need for more power. So they simply added more cylinders and made the engine progressively bigger to get more horsepower out of it. From 1903 to 1923, you've gone from 12 to 300 horsepower in the form of a large 12-cylinder engine built by Rolls-Royce. The trend for adding cylinders and increasing performance continued. And somewhat later, there's this engine, which is now a radial engine. We've got 18 cylinders. And the performance of this engine and the power to weight ratio was improved by adding a supercharger. You can't see that, it's at the back. Now, the addition of a supercharger gives the engine more power at higher altitude. Now, this is clearly an advantage in military terms, but also it's a great boon for civil aircraft which can then fly at somewhat higher altitudes out of the weather. Now, you've very quickly seen a tale of greatly increasing complexity here. So much so that you end up with engines like this. This is not all that clear, but you've got a multi-cylinder radial engine with a supercharger on the back, and then around the rear of the engine casing are 3 power recovery turbines. Now, each of these power recovery turbines provides 600 horsepower to the propeller as well as the pistons and cylinders. So ever more complexity. I've tried to portray what I think is the maximum complexity I can find in this combined cycle engine. If you look at the bottom of the picture, the blue arrow is the air entering the middle part of the engine, goes into a compressor. Then it's cooled and another stage of compression before it goes into the cylinders. Behind that is the exhaust system, which itself can contain a combustor system, followed by another turbine to recover the power that's left in the exhaust. This is kind of like going around in circles, but that turbine is coupled to the compressor that started the process off, which is also geared to the front of 2 propellers. So you've got a turbine system driving one propeller, the piston system driving a second one, and these are rotating in opposite directions for perceived gain in propulsion efficiency. So this engine was called the Napier Nomad, and this is a picture of the engine as it was built. You can see the big bowl-shaped thing at the top right, that's the combustion system, and at the bottom, with the opening is the turbine stage. The cylinders, which are laid out in opposing format, excuse me, sorry, there's 12 of them. So you can see the complication of 12 cylinders, a combustion and turbine and 2 compressor systems. This is getting a bit much. And the time is coming when we're going to need to simplify things. An interesting fact about this engine, it's a so-called simpler derivative of a much larger engine that turns out to be 75 liters or 4,500 cubic inches. It's an absolute monster. That's it in its museum guise. You can see portions of it are cut away to see the inside, but that's what these complicated engines looked like of the 1950s and 60s. This is the drawing of a layout of an even more complex thing. You've got the engine in the front of a military aircraft with the exhaust going all the way back to behind the pilot, where you have a turbine system, a supercharger, and an intercooler. So these things are extremely complicated with the anticipated effect on reliability. Here's an early turbojet designed by Sir Frank Whittle in the UK. I think that this simplification was almost inevitable, having seen the complexity of piston engine aircraft. You can see at the front one compressor stage, and at the back another turbine stage, and in between a combustion system. Virtually only one moving part as opposed to the several hundreds thousand on the complex piston engine. In Canada, about this time, there was the start of the PT6 chapter. This is a photograph of an old brochure from Pratt and Whitney Canada. You can see the date is 1961. Adding a gearbox and a propeller to the turbojet design of Sir Frank Whittle did not materially add to the complexity. Now, this family has gone on to become an icon for the success of the whole Canadian aerospace industry. Where does an engine like this come from? Who starts the process off? We'll talk about that in a little bit. Here's a cartoon of the engine installed in a Beech King Air, which itself was a very competent and very successful airplane. The PT6 itself was a success right across the board. We have it in passenger aircraft, agricultural aircraft, utility, military trainers, and high-speed personal transportations. I talked about the PW100 as being the enabler. Well, where did that engine come from? It really has its genesis in the Beech King Air, really. This was a successful aircraft powered by the PT6, designed and built by Beech. Their competitor in the marketplace was Cessna. That company had an eye to build a competitor to the King Air, but they wanted something a little bit bigger and a little bit faster. And there was some dialogue between Pratt and Whitney Canada and Cessna about building a 2,000 shaft horsepower engine. At this stage, I think it's worthwhile just looking at the way things were done in those days. I think the younger people who've tuned in will recognize that mathematical modeling is now a fine art, and it's very, very refined. At one time, the mathematical modeling of an engine, the desk of an analyst doing that modeling would look a bit like this. You've got in the middle a compressor characteristic, which is a chart of pressure ratio and RPM and mass flow. The other charts are similar. There's a characteristic for a turbine there. So the analyst's job would be to estimate how big he would want these things or she would want these things, then do the power calculations to balance the input required by the compressor to the output available from the turbine. So these sorts of calculations would take place over a matter of days rather than milliseconds. So the state of the art and analysis at that time was just hand calculations using slide rules and hand calculators. The early days of computer applications meant that experimental data could be harvested, non-dimensionalized, and scaled to use for technological forecasting. It wasn't possible to do true parametric analysis. As soon as the schemes to do practical calculations came in, this is a sort of chart that people produced. It's hard to see from where you are, I'm sure, but you've got several hundreds of gas turbine cycles calculated here over a range of pressure ratios, turbine inlet temperatures, and mass flows. So the computer schemes were quite a breakthrough in the engine cycle optimization was really possible rather than impractical. So I've said we moved from hand calculations to true cycle applications. Now, some of the considerations of that were the technology risk. The design and building of an engine is something which takes place over 4 or 5 years, maybe even longer these days. So to do a series of calculations at one technology level is risky. You have to be able to forecast what the technology is going to be in terms of pressure ratio, efficiency, materials, and so on, when the engine goes into production to remain competitive. The other consideration is where to optimize the cycle. Since we've said we can now optimize the cycle, where to do that? Will it be takeoff, cruise, or some intermediate condition? In the case of small turbofan engines, small turboprop engines, the engine is required to pressurize the aircraft as it flies. This, the bleed air to pressurize it is a loss to the cycle. And it's necessary to take that into consideration. It was not possible to do such detailed calculations when we were using a slide rule and charts. There's also a performance risk, because if the performance is not accurate, then the guarantees that the airline customers will require would not necessarily be met. So you'll be selling an engine to guarantee a certain horsepower level at a certain fuel consumption level. So there's technology risks. There's a decision to be made as to where to optimize the engine cycle, and then pitching the performance so as to be competitive in the marketplace is also important. Now, in the case of the PW100, it wasn't just Cessna that were interested. I should mention there's a somewhat complicating factor in there, which is why we don't see a Cessna turboprop with a PW100 in it, and that was the so-called oil crisis of the early 1970s. The price of oil was rapidly increasing due to OPEC, and the idea of a new airplane to Cessna was not one they thought they didn't think the market would materialize. So, in fact, there was a general downturn in the aerospace industry at that time, with the price of fuel going up. Excuse me. It was at this time that I worked at Pratt and Whitney, and they made a decision, having started the PW100 family of engines, and they would continue on through in the hope that they would be ready when we came out at the other side of the so-called oil crisis. In fact, that's what happened. There were other companies involved, other companies interested in getting involved, and that was de Havilland that we spoke about before. There was British Aerospace, Aerospatiale, Embraer, and others. What happened to the program? This is a milestone chart of where the program was at the time. So you can see in 1983, the first engine was certified and entered service the following year. A growth version of the PW100, the PW150 was shipped first in 1998. And of course, we celebrated the 30th anniversary of the certification and entry in service in those years that you can see there. Now, of that family, more than 8,000 engines have been shipped with an accumulating running time of over 160 million hours. This depicts the fleet that's out there at the moment, the variants in the fleet. And you can see that there's Airbus ATR 42, CASI CN395, Bombardier Q100 through the 400, and one not to forget the water bomber, the 215T and 415. There's Dornier, and two projects that were quite small in volume, an Ilyushin, a Russian and a Chinese project. In summary then, from the engine point of view, the PT6 family is still going after 6 decades. It's grown with the industry from about 500 to over 1,500 shaft horsepower. And it's a focal point for an industry, the industry's reputation. Despite what the company thought in the early 70s, it doesn't need a replacement. And the Pratt and Whitney 100 family fits in alongside the PT6 quite nicely. And it's still the leader of the pack after 30 years. And I think the PW100 is a worthy successor to the PT6. In summary about our industry, it's a major contributor to Canada's GDP. It's a world leader in simulators, aircraft, rotorcraft, and engines. And I haven't mentioned before, but it's similar in size to the air transportation industry, the automotive production industry, and oil and gas, and mining and quarrying. So we sometimes lose sight of the fact that Canada's aerospace industry is a major contributor to our GDP, and I hope it continues. Dare I say it, but everybody needs a Columbo moment. If you remember Inspector Columbo, he would walk out the door with one final question. So here's mine. Pictured on here is the railroad spike. And that's a strong symbol of building Canada east to west. Sneaking or coming in from the right is a power turbine blade out of a PT6. I have to say that that's a time expired blade. And to me, that's a symbol for transportation links that join Canada north and south, as well as east and west. So that's a short overview of what I think of as the success story of our aerospace industry. So I have to say thank you for listening, and we'll see how we're going to deal with questions in this new virtual environment. Thank you.
Thanks very much, Bob. That was very interesting. I haven't seen, I've seen a few questions come in. I guess one, which maybe is a starter one that I could do for Gary Elfstrom, is for you perhaps to comment on the partnership within the Canadian, I guess what we now call the supply chain, or the partnership environment for those kind of technology developments. And I think Gary was pointing out the support from the National Research Council, but I think there's probably a whole other layer of other partners in Canada that were essential and maybe part of delivering these products at the end. So could you comment on some of the other people that were involved in this? And I mean, part of that is the partnership between Transport Canada and de Havilland over the years.
Well, the partnership between industry and government is there at the outset, of course, with the support, the financial support as the program gets going, and it's also strongly the support is strongly there when it comes to the certification program. There's a lot of expertise at Transport Canada, and they've done a lot of good work over the years with the industry. When it comes to technology, yes, you're right. NRC has played a big role in the past. And in fact, there were a number of test facilities at NRC which were unique in the world. the companies use.
Okay. Other comments here. I guess the other comment that Malcolm Imre has made was that the PT6 development continues, that they're looking at adding electronic controls to that to bring an engine which is, from the 60s into the, into the middle of the 21st century. So that is indicative of sort of the continuing innovation and response to the market. I guess the comment that I would make, that I tried to put in the announcement for the meeting, was that there's great technological success in terms of the aerodynamics of short takeoff and landing in these, but also the sort of the wisdom and business sense of the people that were developing these products to know that it wasn't just an innovative product, it was one that was going to sell hundreds of airplanes. So these were commercial successes as well as technology successes that Canadians should be very proud of.
Jeff, I think the best way I can answer that is, as a young engineer, I worked on the engine for Concorde and for the engine in the Harrier, the Pegasus. Also on the PW100, to a much lesser extent on the PT6. It's interesting to note that the Concorde and the Harrier are both in museums now, and the Dash 8 is out there making a good living for a lot of people.
Yeah, good.
That's the Canadian way then.
Well, it maybe the long-term solution is the good one, or the wisdom of knowing something would have legs to keep going.
Yeah.
Other comment, Malcolm was making a comment about the fact that the PT6 also had so many applications in the helicopter market, so that there are so many PT6s and that the follow-on families of turboshaft engines that Pratt was also able to impact the world with that too.
And I'm glad that that point's been made, because in my presentation I concentrated on like a narrow slice right through the industry, whereas there's all manner of things going on alongside it. The water bomber, the Bell helicopter, and we shouldn't forget CAE, who's the world's leading supply of airline training simulators. So that's an important point. It's not just a one-trick pony, this industry of ours.
Okay. Question from Avram Goldman. What challenges do we face in terms of CO2, competition from other nations, and virtual travel?
Thanks, Avram. How are you doing? Yes, these are all good points. I did see a couple of days ago that Airbus have announced a range of zero carbon aircraft, and the plan is to power them with hydrogen. So where you get the hydrogen from in a non-polluting way is to be seen in the future, and also the infrastructure to store and supply hydrogen to these aircraft is something else that we need to address. The zero emissions airplane, I think, is going to depend on battery technology. The weight of batteries to power an airplane at the moment is really prohibitive. We're looking at an energy density about 100, between 100 and 200 times worse than kerosene. And that makes designing an aircraft very difficult. But, as you saw in my presentation, the Wright engine gave 12 horsepower and weighed 200 pounds. I mean, that's untenable by today's standards. So we're going to get there. I'm confident.
Okay. Yeah, so there's interest in the chat room on efforts on electric hybrid and hydrogen propulsion. And we'll address that in an upcoming meeting, probably in October, that I'll talk about a little bit later. Malcolm also talks about a hybrid turbo-electric concept that he thinks Pratt and Whitney Canada is looking at.
Oh, you said the same thing as me, Jeff. We've gone back to the CASI logo screen. That's fine.
Okay, I just have to get back to my questions here.
Good.
Okay. Curtis Kramer was one of the people talking about electric hybrid and hydrogen propulsion. So do you think Canada has a role in that? Do you see activities? I know NRC is working on an electric propulsion project with a twin engine aircraft. Any other knowledge either you or people on the call today have of that? Let me know.
There is a project to re-engine a Beaver in Vancouver. I believe this has flown.
Right.
And that the routes that Harbour Air and the other airlines in Vancouver and the Islands region fly, it's feasible. I'm not sure how economical it'll be, but at least they've put an electric motor on a Beaver, and it's been operation. That I should put that in my presentation, shouldn't I? Look at what the Beaver's doing now.
It's continuing to fly, and people would say you can't have an electric aircraft because it doesn't have the range, but there's another case where adapting a product to a specific market, they don't need it to have long range. They're flying from Vancouver to Victoria, and that suits their purposes to have something with that range and the same or better performance perhaps.
Oh yeah, yeah.
Okay, where we see a note from Al Conrad, who says hello and thank you. He recalls the air cushion landing system that was used on the Buffalo and that AT had a partnership with. Have you a comment on that?
The air cushion landing system on the Buffalo, what a great idea, because you can fly off more or less any terrain. The only thing is, it's hard to generate side force with an air cushion. There's no way to stop the aircraft going downwind or downhill at low speed.
Okay.
Now you can yaw the aircraft by differential thrust, but it's still going to head downwind, whichever you do. And that was, as I said, it was a great idea. And on that particular air cushion, down each side, there were supplementary pads that could be inflated to push down on the runway to create friction, but that still only dragged the aircraft in. It still only provided off-center drag, which yawed the aircraft. It didn't really generate much side force.
Okay, thank you. Tom Lukowski, I think, is looking for if you could give a little more update on what you think Viking Air has been up to and the additional production or them owning the type certificate for the -7s and the Twin Otters, whether that's going to be a continuing market or a continuing export for Canada.
I visited Viking a long time ago. They seem to be really well set up. The transfer of the type certificates by Transport Canada is a recognition that they have the infrastructure in place to take care of the design, not just the production. They have indeed taken over the type certificate, the responsibility for the type certificates from of all of the de Havilland products up to the -7. So they have the opportunity, and I think that it will be a success because the need for these utility aircraft will continue. But I did take a quick look at the Viking Air webpage, having gone through my notes to make sure it was still up to date, and in fact it's well developed, and they seem to be doing rather well.
Okay, thank you. Question from Michelle Baxter. How big a threat to the PT6 will GE's new catalyst turboprop be? Whether you know that or somebody online would comment on that.
I don't know of that, but there's all sorts of threats.
Okay. Malcolm had a comment about the business success of the de Havilland aircraft. He said Dash 7, for instance, is and was a great technological success, but not a good business sense, while the Dash 8 is both. Canada really has a great reputation in the development of utility and special purpose aircraft. I think we as a nation should stay focused on the market, and I'm encouraged and extremely encouraged to see that Viking is putting a lot of effort into improving the Q400 and the water bomber after Bombardier did not do so as their attention was focused elsewhere. Any further comment on that sort of?
No, I fully agree that the Dash 7 was not as strong a commercial success as it could have been. I think the fact that it couldn't fly fast enough, the fact that it had 4 engines, which imposes an additional maintenance burden, meant that it wasn't going to sell in hundreds. But having said that, some are still in service. The last I heard, that was the British Antarctic Survey was still using them. Think on the philosophy that it needs to be able to land and take off very slowly in the Antarctic, and they want a 4-engine airplane because there is a great distance of ocean to travel over before you get to your destination.
Okay. Another comment, perhaps you could comment on 1 or 2 ways you believe Canada can emerge from the pandemic as a continuing global leader in the aerospace industry, and secondarily, whether this could be accomplished with or without government involvement. In 25 words or less. 25
words or less. I think I'm going to work on that, and then I'll let you know when I make a fortune with my. That's the most important question facing us. I think how to go through the COVID downturn and come out the other side. If you look at the aerospace industries associations, they're working at the moment to understand this very question. There's the Aerospace Industry Association of Canada and AIA in the States. And I was reading some presentation by the chairman of the AIA in the States, and amongst the things that they are prioritizing, the American industry, is the preservation of the highly skilled, well-motivated workforce. So I think tactically, the industry would be well placed to by supporting the workforce, and strategically seeing how we're going to develop the replacements for the people that are retiring. The workforce is very, very important.
Okay.
Can we do it without government support? Certainly one would like to think so, but globally, governments have decided as a matter of policy to have an aerospace industry and are prepared to support. The European government places significant importance on the aerospace industry and is providing massive support. It makes some of the measures which our government provides to our industry look quite small. But then there's a lot. Europe is a lot bigger than Canada, so I'm not being critical of the way we're supporting, but it's the global way of doing things.
Well, and the related comment to that, I would say from de Havilland, the readings that I've just done on de Havilland, a lot of the launch customers for those early de Havilland Bush planes were the U.S. Army, that they designed the Otter to a kind of a U.S. Army specification, and the same with the Buffalo and Cariboo. Most of those designs came and were launched with U.S. Army orders.
But
so there's different ways of having government support, I guess.
Yeah, to give credit where credit is due, de Havilland won the competition in the face of 8 U.S. competitors. So, we're good.
Yeah. a couple of, here's one that I won't identify who asked the question, but from your amazing career, can you provide a perspective on, I'll edit a little bit, how Transport Canada helps innovation in Canada?
Where can I start? Yeah.
That's a whole other talk, maybe.
It is. The importance of the regulatory support function is really there, because if you read a regulation, you can always find something in that regulation to stop a project. The need to be creative and to interpret in a pragmatic way the regulations as they're written is ever present. And we have been, and this sounds a bit self-serving, and I apologize for that because I worked there for 20 years, but Canadian industry has been well served by Transport Canada over the years, because A, they're tough, they were tough, and B, they have a great reputation around the world for being tough. So a strong regulator is part of a strong industry.
Right. And I think, as an example, one of the reasons for the Twin Otter's early success as a commuter airliner was that the size of it would handle 19 passengers, which got them out from being sort of having to do the full safety and meet all of the other federal aviation regulations that you would if you'd had a 20 passenger airliner. And so they designed kind of to that guideline and were able to create a whole niche in that commuter airliner, or to create that niche, which was the commuter airliner one. Is that right?
Yeah, that's right. That's right. And you use the word niche, and I think the Canadian industry's success has been built on identifying a niche and really being very successful within that niche.
So your point earlier about the Transport Canada role was that if something was designed in Canada to the regulations that Transport Canada was supervising, or in fact these days delegating, it had the confidence of the rest of the world, where often the starting or the substantive market was. So in that respect, a certification from Transport Canada was a valuable thing to have.
Yes, that's true.
Okay, next question. I hope people are willing, the people who are really hungry have left to go and have their beef bourguignon that they've made for themselves. People that are still savoring Bob's answers will stay. We have a couple of more questions. Dan Kirkham was asking, is there anything going on in Canada in the space tourism area that you or other people know of? That might be another topic for an evening.
Yeah, we'll give the Governor General a call to get an answer to that one.
A number of thanks from friends of yours, Dave Zimick in particular, Avram. We have some Mathers from Vancouver who might be related, so we might not take their praise for the conference to be totally independent, but we're glad we could have your family be able to connect with you even though you can't go and visit them. Malcolm Imre has a comment further to the GE Catalyst one that says that his opinion, it is a real threat to the PT6. Cessna has selected it for their answer to the Pilatus PC-12. On the other hand, Cessna selected the PT6 for their new Sky Courier aircraft.
Yeah, the industry technology does not stand still, and it would be interesting to hear from some folks who are still at Pratt and Whitney as to what their thinking is. I'm sure from a competitive point of view, they wouldn't want to give too much away, but that would be most interesting.
And a comment from one of my classmates from U of T from a long time ago, Adrian, Greetings to you and thank you for joining. He comments that Dash 7 has found a new life up north with Air Tindy. I guess 5 aircraft, and Trans-Canada Air, aka City Express, with 13 aircraft. So that's good news. I think those are all the questions. I'll give another 10 seconds for people to quickly type burning questions or comments that they have. There they go. So the PT6E from Avram is the world's first small turboprop with a full authority digital engine control, a new step in innovation. Pratt and Whitney Canada has been involved with Virgin Galactic, supplying 4 PW308s for the White Knight 2 carrier aircraft and to lift spaceship aircraft to high altitude for release. So Canada continued their role in space, not just with satellites and as a member of the European Space Agency, but also to be part of this new commercial airline. I think that's it for the questions. Have you got a closing comment that you'd like to make? I have a short thank you for you.
No, I don't have any closing comments. It's just to say that I'm not really comfortable with this environment yet, but I'll get there.
Well, we're tasking you enough that you're going to be so good at it that we'll having to watch you on the Emmys or something next year because you'll have gotten so good at it.
There's always hope, Jeff.
Just as a thank you, I'll continue on the hors d'oeuvre theme to whet your pre-dinner appetite. Bob, thank you for drawing this innovation smorgasbord together for us. It does show out the accomplishments in the art and business of Canadian aviation innovation and shows the ability to create products when we look at the production numbers of the aircraft and engines. I'm sure some people knew of these unique Canadian successes, but I hope we're all a little bit more informed and a little bit more inspired. This compilation, though, is a source of pride and hopefully inspiration for all of us in these difficult times. Thank you for your time and initiative to help sustain our CASI community in these difficult times. We will, I can hear a lot of virtual applause and it looks like a standing ovation. Many thank yous in the chat room for you. I will take a second before people actually go for dinner to point out our next meetings. In October, we're planning to continue this design innovation kind of theme that Bob's talk started this in September with the support of the student groups as well, and with Jeremy Laliberte at Carleton. To talk about a design challenge, which is one that he's putting forward, which would be a Canadian modular vertical takeoff and landing aircraft system, which he's proposing, and we might work together within CASI on an integrated autonomous mobility that would be unique to the Canadian mission and be useful for inspiring Canadian students. So look for a notice for October for another hors d'oeuvre like this. For this design challenge. In November, we're looking at kind of a community development talk that would be maybe more along the lines of a career evening. It follows and ties in with the Carleton Mechanical and Aero Society's industry evening, where students get together with employers and talk about what's needed, what's available, how do you stand out when you're applying, what's a good idea for continuing professional development. We have another talk that we're lining up, haven't set a date for it yet, on sustainable aviation, which will have a strong innovation and entrepreneurial highlight. Just in closing, I'd like to thank everybody for joining and for their continued support for the community, and I hope this is helping through this difficult time to keep people a bit connected. Please do look for ways to connect with other people through CASI. We can try and help you if you want to email back with ideas for other talks. Bob is getting so good at it and he has so much knowledge. We're happy to have him speak again, but I noticed that we have a number of other people who could give probably very interesting talks for this. So I think I see that we're just collecting some thanks from many, many people who were on, and we'll let you go to your dinner, all of you, and especially Bob, thank you for your time. And Todd and April from CASI and Jeff Langadoc for CASI support, thanks a lot, and we'll talk to you again soon. Good night.
Thanks very much.
Thanks for your help, Todd and April.
We're happy to help.
Thanks, Todd.
You're welcome.
Okay, we'll talk to you
Bye.
soon. Good night.